Welcome back. Today I want us to look at more about fractional indices. We have looked at simple fractional indices. Let's just do a recap on that one. So let me just increase the size of my pen. Alright, so let's just do a recap. So we have looked at 81 to the power 1 over 2, and we said this one is the same as finding root of 81, which is 9. And we also looked at 243 to the power 1 over 5, and we say this one is the same as finding the fifth root of 243, and then the fifth root, that is to find a number that you multiply by itself 5 times to get 243, and you got that number is 3. Okay, so now I want us to look at more about fractional indices. So let's consider an example like if we have a to the power, let me use a different color. So if we have a to the power 3 over 4, a to the power 3 over 4, what does this mean? How can we simplify this one now? So now you should remember that 3 over 4 is the same as 1 over 4 times 3. It's the same as 1 over 4 times 3, or we can write it as 3 times 1 over 4. Now, so recalling this is going to help us to write this power in this way now. So we are going to go back to the second rule. Remember the second rule of indices, we said a to the power m to the power n is equals to a to the power m to the power m n. So what we do here, we multiply the indices. Now let's look at our problem here. We have a to the power 3 over 4. So I want us to write 3 over 4 this way, in this way, or using this format: 1 over 4 times 3. Let's start with that one. Let's write 3 over 4 as, so now this problem is a is equals to 1 over 4 times 3. So you will understand that this is the same as this. Okay, so now we talked about simple fractions here. What is the meaning of a to the power 1 over 4? So this one is to find a number that to multiply by itself 4 times to find a. So this one is the same as this one is the same as the fourth root of a times 3. Now, so we can write this as the fourth root of a times 3. So this is a not 9. So the fourth root of a times 3. Okay, so let's make an example whereby we will use numbers so that it improves our understanding. So let's make an example now. So let me take a different color now. So let's look at this example. We have 16 to the power 3 over 4. 16 to the power 3 over 4. So this one we can write as 16 to the power 1 over 4 times 3. 16 to the power 1 over 4 times 3. And 16 to the power 1 over 4, we know that 16 to the power 1 over 4 is the fourth root of 16. So this is what is in brackets. So we are writing it this way, and then we bring this 3 to the power 3. So what number, if we say the fourth root of 16, we are looking for a number that will multiply by itself 4 times to give us 16. Then we will find that that number is 2 to the power, then we bring this 3 to the power 3. Then this one is going to be 2 times 2, 2 times 2 times 2, which is 8. So now we have simplified this problem. We've simplified this problem. 16 to the power 3 over 4. All right. Now, so this is one way of finding it, or we could still work on the same problem now. You remember that we say 3 over 4 can be written as 3 times 1 over 4. So this is another way of writing 3 over 4. So now let's look at the problem. 16 to the power 3 over 4. Let's write 3 over 4 this way now. So this gives us 16 to the power 3 times 1 over 4. All right. So then this means we have to find the fourth root of 16 to the power 3. So our answer is going to be the fourth root of 16 to the power 3, or 16 cubed. Then you can get your calculator to find the cubed root of 16, and you work out, you find the answer. So you're still going to get 8 to be your answer. Okay. Now I want us to look at more examples. Then we are going to come up with the generalization. So let's look at another example. More examples. So let's look at 8 to the power 2 over 3. So this one we can write as 8 to the power 1 over 3. I prefer this way because it is easier to find the powers of smaller numbers. So so it's 8 to the power 1 over 3. Then we know we can simplify this one. So this is the cubed root of 8 to the power 2. The cubed root of 8, we know that the cubed root of 8 is 2, and then squared. So this one gives us 4. Okay, so we could still work out the same problem by, when we say 8 to the power 2 over 3, we can write this one as 8 squared times 1 over 3. I do not recommend this one because this tends to give you a bigger number. So it is easier to work with small numbers like this one. So I would recommend this method, simplifying it with this method. However, this is still correct. Okay, so here we get 8 squared, which is 64. 64 to the power 1 over 3. So now you can see that this number is big. So you can imagine if this was 27 cubed, so you'll still find a very big number. All right, so this one is going to give us the third root of 64. The third root of 64. So a number that you multiply by itself 3 times to get 64. So you will find that the number is 4. So we're still getting 4 here, and we got 4 even here. All right, so I hope that one was clearer now. So now we can generalize here. So we are going to call this one I can't remember how this one if it's rule 6 or rule 7. So So I guess this one should be our seventh rule. Now, what does the rule say? What does the rule say now? Says a to the power p over q is equals to a to the power p to the power 1 over q. 1 over q. So this one is p to the a to the power p. A to the power p over q is equals to a to the power p to the power p, yes, to the power 1 over q, which is the same as the cubed root of a to the power p. The cubed root of a to the power p. Or we can also say a to the power p over q is the same as a to the power 1 over q to the power p, which is the same as the cubed root of a cubed root of a to the power p. The cubed root of a to the power p. So you should understand this this rule. So let me explain it again, so that here we have a to the power p to the power p over q, and then here we get a to the power p to the power 1 over q. So this is the same as finding the cube. So remember what the meaning of negative of fractional indices. So it's q is the cubed root of a to the power p. So this is one way of doing it. Or you find a to the power p over q. So we write this one this way, a over q to the power p. Then you can simplify it to this one. All right. So I will personally recommend this second method of working out this. All right. So thank you very much. We shall then look at more examples to work on that one. So let's just take one example. Let's just take one more example, so to prove our understanding. So we have 125 to the power 4 over 3. So this one is going to be 125 to the power 1 over 3 to the power 4. So we need to find a number that's multiplied by, so like we find the cubed root of 125 to the power 4. A number that you multiply by itself 3 times to give 125 is 5 to the power 4. And then we can work out this one. 5 to the power 4 is 5 times 5 times 5 times 5. So 5 times 5 is 25 times 5, 125 times 20 times 5. So you can use your calculator to find that one. So let me use that mine. 5 times 5. All right. So we are going to get 625. All right. Thank you very much.